Okay, this is energy transformations. We're going to start out with the definition of law of conservation of energy. Okay, and like every other law of conservation of whatever it is, basically says the same thing. Energy cannot be created nor destroyed. Can be transformed. So energy can be transformed into different types of different forms, but we cannot create energy out of nothing. Okay. So just some examples of transformations of energy. You know, if we have burning methane, and methane is a gas that we use in the lab, within the bonds of that methane, you're going to have chemical energy. Okay, that chemical potential energy that we talked about in the last video is going to be present at the beginning. And when we light it on fire, okay, when we light it on fire, we get heat and we get light. So the heat is going to be your thermal energy, and the light is going to be your radiant energy. So anything that creates fire is going to have thermal and radiant energy. Okay. Second example. Say we're going to use an electric can opener. Okay, an electric can opener. First of all, it's just sitting there. All right, it is plugged in, so we have electrical potential energy. Okay, most of these are going to start with some sort of potential energy. So this one starts out with electrical potential energy. And then when we turn it on, we push the button, things start moving. So we end up with mechanical energy. Okay, that's the type of kinetic energy that we transform into. So we go from electrical potential to mechanical because the gears are actually moving. Last one that we're going to talk about, striking a match. Okay, striking a match. First of all, if you think about the match is not going to strike itself on the box. Okay, so we have to physically strike it on the box. So we are putting in mechanical energy. Okay, but on the tip of that match are the chemicals required to start the fire. So we also are starting with chemical potential energy. So mechanical and the chemical potential energy of the match is going to be transformed into fire, which is, as we just said, always radiant and thermal energies. Okay, so some of these you have to think about what's actually going on in the process. All right. Temperature conversions. Okay, another obvious type of energy is, you know, how much heat something has. What's the temperature? All right, we're going to talk about three different scales. So we have Celsius here. We've got Kelvin. All right, and we've got Fahrenheit. That may not even be how you spell it. In fact, I would almost guarantee that it's not. But whatever. All right, so then we've got the boiling point and the freezing point. Okay, boiling point and freezing point. All right, and then in Celsius, all right, we should all know that in Celsius, the freezing point of water, okay, we're just talking about water here, is 0 degrees. And the boiling point is 100 degrees. Okay? Let's skip over to Fahrenheit, because that's what we use every day. You probably know that water freezes at 32 degrees Fahrenheit. All right. It boils at 212 degrees. All right, so then the Kelvin in the middle. The Kelvin is the more scientific one that we don't see a whole lot. Freezing point for Kelvin is 273, not degrees. They're just Kelvin. 273 Kelvin. Okay, it's actually 273.15, but we're not going to deal with the 0.15. Boiling is 373. Okay, again, technically 373.15, but we're not going to deal with that again. There's no degree symbol. It's just Kelvin. Okay. What you'll notice about these two is that they follow essentially the same scale. Okay. There's 100 degrees difference between freezing and boiling and, in the Celsius scale, and there's 100 Kelvin difference between freezing and boiling. So they follow a 1-to-1 scale. Okay. So it's going to be pretty easy to calculate the differences between those. All right. Before we move on, let's talk about absolute zero. Okay. Absolute zero. Absolute zero is a theoretical number. Okay. Theoretical number where all molecular movement stops. Okay, we're talking about no motion, no vibration, no nothing. Okay, and that, again, in theory, is at 0 Kelvin. And I say in theory because we haven't actually gotten there. We've gotten very, very close. Okay, we've gotten below 1 Kelvin, but we haven't gotten to actually 0 Kelvin. So we're not 100% sure, but we have a really good idea that is that's what happens. So at 0 Kelvin, at 0 Kelvin, we're at negative 273 degrees Celsius. So think about how cold that is. You know, a freezer is kept at, you know, probably -3, -4 degrees Celsius. So think of negative 273 degrees Celsius. Think about how cold that is. As far as conversions go, okay, Kelvin to Celsius and Celsius to Kelvin, pretty basic. If you want to go from Celsius to Kelvin, you're going to add 273. If you're at Kelvin and you want to go to Celsius, you're going to take your Kelvin number and you're going to subtract 273. Okay? Those are the easy ones. For converting Celsius into Fahrenheit, all right, we simplify it. Okay? We use what is called the 40 rule. Okay? It's so much easier than having to figure out and remember which one is multiplied by 5/9 and which one is multiplied by 9/5. It's pretty much the exact same every time. So if we use the example of 25 degrees Celsius and we want to know what the degrees Fahrenheit is, our first step is to add 40 to our number. Okay, so if we look at our example, we're going to take 25 plus 40. That's going to give us 65. Okay, the second thing we're going to do is we're going to multiply. Okay, we're going to multiply by either 9/5 or 5/9. Okay. So if you are going from Fahrenheit to Celsius, you're going to use 5/9. Okay, and if you're going from Celsius to Fahrenheit, you're going to use 9/5. Okay, so we're going to multiply 65 because we're going from Celsius to Fahrenheit. We're going to multiply 65 by 9/5, and we're going to get 117. So 65 times 9/5 equals 172. Okay. Last thing we're going to do is we're going to subtract 40. Okay. Step number 3, subtract 40. So 117 minus 40 is going to give us 77 degrees Fahrenheit. Okay. So if you were to look at your, a traditional equation for converting these two, you've got to add 32 or subtract 32 and multiply by one and divide by another. So this is, a little bit more straightforward. You're going to add 40 to whatever you've got. You're going to multiply by either 5/9 or 9/5, and then you're going to subtract 40, and that'll get you the right answer every single time. Okay, so our answer here is 77 degrees Fahrenheit. Okay, that is energy. Okay, energy transformations.